This. You guys learned functions last year in Algebra 2, so this is kind of like a crash course of what do you remember from Algebra 2. When I taught SUNY New Paltz, this was a quiz I gave them, so it's a great little refresher way of jumping right back into functions. All right, so this is my little key here. Now, the big thing about a function, so I'm going to put the definition up here, all right? A function is a relationship in which each element of the domain, and remember domain is your x's, right, is mapped to one, and that's the key thing, one element of the range. So that's what makes something a function, right? So let's take a look at this first piece. In order to be a function, everything in the first circle, which would be our x's, is only allowed to go to one thing in the y column. So this question is asking which one is not, right? So check this out. 3 goes to 4, 5 goes to 4, 7 goes to 6. Each of these x's goes to one y, so this one's okay. This is a function. So I'm going to put func here. Okay? B, check out each of these. Each of these numbers only goes to one of the other, so that's func. Okay? Now, this is a problem. All right, see the 5? See how it goes to 2 different locations? That's no good. So this one is not a function. And, right, each of these is all going to the same 6, but that's okay. As long as each of the x's goes to one of the y's, we're good. Now there's actually 3 ways of looking at it in circle graphs, right? Another way of looking at it is as points. So I'm going to do these 2 as points just so you can see. For A, if I were to write these as points, this one would be 3, 4. This one would be 5, 4. And this would be 7, 8. Okay. And if I wrote this one as a collection of points, it would be 5, 4, 5, 6, and 7, 8. Now, if I gave you points instead of circles, the easiest way to check is look at the x's. See how all these x's are different? That means it's a function. Look at this one. Uh-oh, these x's repeat, and they both go to different numbers. So that's how you could check real quick from points to see if something's a function or not. Do you remember what you use in a graph? Right? So for example, over here, I'm going to give you 2 graphs. I'm going to give you a parabola, and I'm going to give you a circle. Do you remember which one's a function and which one isn't? Well, easiest way to tell, vertical line test. If I draw a vertical line there, it hits the parabola once. If I draw a vertical line here, how many times does that red line hit the circle? Twice. That means x's repeat. So this is not a function. Right? This is. So in a graph, we can use the vertical line test to tell. Okay. Now, with the next question, right? If f of x equals 2x squared minus 3x plus 4, then what is f of x plus 3? So if you notice, right here was just an x, and now this says x plus 3. That means anywhere you see an x in this equation, we want to plug in x plus 3. And we want to do this math out. So this here, I'm going to do off to the side, right? Means we have to do x plus 3, x plus 3. And when you distribute this, you get x squared plus 6x plus 9. So jumping back over here, I bring down the 2. All of this becomes x squared plus 6x plus 9 minus 3x minus 9 plus 4. Okay? So now this becomes 2x squared plus 12x plus 18 minus 3x minus 9 plus 4. Okay, and combining like terms, I get 2x squared, right? Looks like plus 9x. And then 18 minus 9 is 9. 9 plus is 13. So I got choice C for that one. All right. The graph below, a bunch of points. All right. Which point could be used to find f of 2? Well, normally we write f of x, right? So since it's f of 2, and that's in the x spot, we go to 2 on the x-axis, and what is there? A. So a big thing is whatever number's in the parenthesis here always is where you're going to look on the x-axis. Okay. Next one. Number 4, right? Is it a function? And then what's the domain and range? So will this pass a vertical line test? Yes, it will. So it's a function. Okay, is it a function? Yes. The domain is your x's. 1, 2, 3, 4. So we're going negative 4 over, but we're going this way forever. So the domain is solid bracket negative 4 to infinity. Range is the y's. How low to how high? Well, it goes from 0 and up. Okay, now this is something called a step function. It looks like a staircase. Right? Now, I did call it a function, so this answer is going to be yes, and let's talk about why. Technically, there is a point over another point here, but if you notice, that's an open circle, and that's a closed circle. Open circles are okay, because that means there's really nothing there, so that passes a vertical line test. So that's the yes for is it a function. Now, the domain, how far to the left do we go? Negative 5, it's positive 5, but it's an open circle. So soft bracket 5. 5 goes to 7, 7 goes to 9, 9 goes. So it stops here, 15, and it's a solid bracket. Now what's special here is the range. We are not going from 1 to 5. Notice we're at 1, but are we at 1.5? No. All right, see how it jumps? That means our range is going to jump. That means we used the number 1, or we jumped up to the number 5, or we jumped up to the number 3, then to 4, then to 5. So check that out, all right? And anytime you have a step function, it's going to leap like a staircase, so does the range. It leaps. Okay, is this a function? Will it pass a vertical line test? And I hope you're thinking no, it fails right here. So if I draw a vertical line right there, that's a no. Okay? Domain, we go all the way to negative 4, and it's a solid dot. And we go all the way to 4. Range, the lowest is negative 1. And then we go all the way up to 3, it looks like, solid dot. Okay? And finally, the last one, is it a function? Yes, because it's going to pass a vertical line test. The domain, the x's, see the arrows at the ends? That means we're going everywhere, so that's all real numbers. And range, let's see, 3, 4, 5, 6, 7. It looks like negative 7 and up forever. Okay. All right, now this next section is what we call piecewise function, because there's 2 pieces to the graph. We have this little parabola part and then the line part. And we got to figure out which of these matches this picture. Now, the way you would do this is you're going to make XY charts for these. So for example, this one, I would make 2 XY charts. One for x squared, and one for this guy. So for x squared, they want me to start with 1 and plug in numbers smaller than 1. So 0, negative 1, negative 2. So if I plug that in to x squared, this would be 1, 0, 1, 4. Let's see if that part works. Now, notice this does not have a line underneath it, so it means that 1, 1, it should be an open circle, which it is. Then we have 0, 0, negative 1, 1, negative 2, 4. Okay, so this part worked. Now, let's do this part. Start at 1. We want numbers greater than 1, so we're going to do 2, 3, 4. So if I plug 1 into my equation, 1 minus 2 is negative 1, 2 minus 2 is 0. Does this match this picture? No, it does not. So that means that's off. So it looks like all the x squares will work, right? We just need to figure out which of these equations matches this. Well, these are all lines, so let's do a quick line review. What is this in the equation for a line? I hope you're thinking, hey, that's the y-intercept, right? Is there a y-intercept at negative 7? No. Right? Does this look like it'll have a y-intercept at positive 1/2? Yes, it would. So the answer here would be B. Right? That's the quickest way to finish it. All right, now let's take a look at this one. Which statement is true about the graphs of f and g shown here? All right, so the first one says f is a relation, g is a function. Relation just means it's a picture. It doesn't mean anything special. So is f a relation? Check this out, right? G is a function. Well, g is definitely not a function because it fails a vertical line test. So anything that says g is a function, I'm getting rid of. Okay. F is a function. What do you think? Yes, it is. This passes a vertical line test. So f is a function. That's good. G is a relation. That would be correct. G is not a function. It's just a relation. So that's just B. All right. Okay, this one we actually want to graph our own piecewise. So we're going to do what I discussed before. We're going to make two XY charts. We're going to do an XY chart for the absolute value. And after we're done with that, we're going to do an XY chart for 4. All right. So the interval they want us to use for this is to start at negative 3 and go up to 1. Okay. So if I plug negative 3 into the absolute value, it's positive 3. Positive 2, positive 1, 0, 1. All right, so I'm going to graph this now. At negative 3 over 3. 1, 2, 3. So here's negative 3. 1, 2, here's 3. I always like to put a scale. So at negative 3, 3, and I'm going to look here to see if it should be a solid dot or an open circle. There's a line underneath it. So this is going to be a solid dot. 1, 0, 0. Now, 1, 1, look here, there's no line. So this needs to be an open circle. So this is the first part of the graph. Then I'm going to do an XY chart for the next part. So 4, do X, Y, right? And it wants us to start at 1 and stop at 8. 1, 2, 3, 4. Okay, so I start at 1 and at 8 because that's my interval. Now, what's interesting is it's just the number 4, so that means there's nothing to do. They want us to have every single one of these before. So now I'm going to plot this. Now notice these are both lines, so it's closed circle. So at 1, I'm going to be at a solid out of 4, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to connect those. Oops, I made it sloppy. And that's what the picture looks like, a little like almost like a backwards check mark and then a flat area. Okay. Given this function, find the average rate of change over the interval x equals a plus h. All right, what does average rate of change mean? Right? That's a fancy way of saying the word slope, right? And what is the slope formula? Subtract the y's over subtracting the x's. So that's what we want to do here. So I gave you two x's. This one here is going to be x1. This one here is x2. So the first thing I'm going to do is make a fraction bar. I'm going to do this part first. x2 minus x1. So that means I'm going to do a plus h minus a. Now, y2, that means this is your y, right? What we're going to do is take this and plug in a plus h where we see the x. So I want to put this in a bracket. I'm going to do 3a plus h squared minus 2 times a plus h. Boom, boom, boom. So this right here represents y2. I took the equation and I plugged in x2. Now I have to subtract from that, let me make another bracket, y1, which means go to this equation and plug in x1, which is a. So it's going to be 3a squared minus 2 times a. And now this is what we want to solve. All right, so I'm actually going to jump to another piece of paper so you can see a little better. So at the moment, I've got 3a plus h squared minus 2a plus h minus 3a squared minus 2a. Right? All over now. If you subtract off the a here, what would we be left with? H. All right, now step 1, I have to distribute a plus h squared. So over here, we do a plus h, right? So if I distribute this, I end up with a squared plus 2ah plus h squared. So that's what's going to go right here. So bring down the 3. All of this is going to get replaced with the stuff I found over here. So I'm going to put a squared plus 2ah minus, I'm going to distribute this. Right? So this minus 2 goes to both of these. So this is the first part. Then I'm going to subtract this. This would be minus 3a squared plus 2a all over h. Now, I'm going to distribute all this. So here we go. So I know there's an h in the denominator. This gives me 3a squared plus 6ah plus 3h squared minus 2a minus 2h minus 3a squared plus 2a. Now, if you do this right, you should notice some things are going to cancel. Like 3a squared will go with him. 2a is going to go there. So that leaves me with 6ah plus 3h squared minus 2h all over h. Now, look at all these. What do they all have in it? They all have an h. So I'm going to factor out an h. Oops, that's nice. And then that cancels. And this, after all that work, is your final answer. So don't worry if you were struggling with this. We are going to practice a lot of these in a couple of days. So that's going to be the bulk of our unit is working on these. So don't stress too much yet. All right. Next one here, number 12. We have this crazy equation, and it says f at 1/2. Now remember, whatever's in the parentheses are x. So all I'm going to do here is every time I see an x, I'm going to plug in 1/2. Right? So 2 times 1/2 is 1, so it becomes 1 plus 3. 3 minus 5. So that's radical 4 over negative 2, which makes 2 over negative 2. So I'm getting negative 1 for that answer. Okay, and finally the last page of this. Find the domain. All right, so you just had a quiz on this. You did very well on it. I'm just going to zip through this real quick. You can't have negative 3 in the denominator, right? So this should have been negative infinity to negative 3, or negative 3 to infinity. This isn't a fraction or a radical, so it's all real numbers. All right, now, radicals. So that means we can't have negative 6 and 6. It's not a fraction, so solid dots. If I plug in 7, it works. 0, it fails. And negative 7 works. So for this one, you should have had negative infinity to negative 6, solid bracket, or solid bracket 6 and up. All right, letter D. Negative 2 would ruin it. And since it's in the denominator, we cannot have it. Then I'm going to test. I'm going to plug in 0. 0 works, right? But -3 does not. So this should have been soft bracket -2 and up. I'm going to skip over e for 1 second and do this one because it's quick. It's not a fraction. It's not a radical. So it's all real numbers, right? And then this one I'm going to do over here off to the side. Radical x minus 2 over radical x plus 7. So I have to do dueling number lines. Right? What ruins this one? +2. What ruins this one? -7. Now, this is in the numerator, so it's a solid dot. This is in the denominator, so it's an x. Now, I'm going to test. Okay? My top here, I'm going to plug in a 3. 3 works. Right? Plug 0 in, it does not. Plug -6 in, that works. Right? Plug -8 in, it doesn't. So the answer here is where it overlaps. So the answer to E is going to be solid dot 2 and up. Okay. And finally, which of the following of these are functions? Now this is probably the easiest way for me to describe it to you. Remember before where the circle failed? Right? So circles are a no for a function. Let's say this radius is 3, and the center here is 0, 0. The equation of this circle is x squared plus y squared equals 9. Okay, now, remember before where the parabola was a function, and the equation for a parabola is y equals x squared. Okay, what does this have that this doesn't have? And I'm hoping you're noticing this guy. Any equation with a y squared can never be a function because it'll have a sideways curvature. Excuse me. So let's take a look at this one. So this equation right here, notice x is squared, but y is not. That means this would be a parabola, a happy-faced parabola. So this would be a function. All right, letter B, notice nothing is squared. That means it's a line. So I'm going to put here, this is a happy-faced parabola, right? This one here would be linear, so that's a function. All right, see here, 2 squares with a plus sign between it. It's a circle, oops. So not, right, because it's a circle. All right, what does an absolute value graph look like? A V. Is that a function? Yes, right? All right, right here, see this y squared? Y squared means it's a sideways parabola. So this is not a function. All right, and finally these two. Y equals 4. What does that look like if you graph it? Here's your x-axis, here's your y-axis. Y equals 4 is a horizontal line like that. Is that a function? Yes, it is. Right? And now this guy, I'll bring down here, x equals -2. Well, here's your x-axis, here's your y-axis. Here's -2, right? That's a vertical line, right? That's actually the test, so this is not a function. All right, and that's a crash course of functions.